Section 6.3, Dividing Polynomials. Here we have two examples of division. Here we have 7 dividing into 42, and we can identify the parts of our division. Our number 7 is our divisor, 42 inside our division symbol is our dividend, and our solution we have is a quotient. And remember the process, we just want to figure out 7 times what gets us closest to 42. And that happens to be 6. 6 times 7 is 42. We change the sign, and we subtract. 42 minus 42 is 0. We do not have a remainder. Here, 3 times what gets us close to 28? That would be 9. And that would give us 3 times 9 is 27. Change the sign. 28 minus 27 is 1. We have a remainder of 1. When our divisor and quotient go evenly into our dividend, then we say that those are factors of that dividend. Therefore, 7 and 6 are factors of 42. Since 3 and 9 do not divide evenly into 28, they are not factors. So we can say when numerical division has remainder of 0, then the divisor and quotient are factors of the dividend, which is what we said here. 7 and 6 are factors of 42. 3 and 9 are not factors. And let's recall from the last section that we know factors determine zeros of a polynomial. And if we have a remainder of 0, those are factors of the polynomial. Therefore, those are zeros of the polynomial, which are solutions of the polynomial, and also x-intercepts of the polynomial. Let's begin. If you divide a polynomial by a monomial or another polynomial and the remainder is 0, then a divisor and quotient are factors. That's the same as our last slide. If the two numbers divide evenly into our dividend, they are factors. So here, if a monomial and a binomial divide evenly into a polynomial, have a remainder of 0, then those are factors. In this case, the divisor and quotient are not numbers, but both are polynomials. Let's take a look at an example. I want to divide a polynomial by a monomial. I want to divide each term of the polynomial by the monomial. Here I have my dividend, and this is my divisor. So I'm going to set this up just like my numerical example. My dividend and my divisor. Now I want to multiply my divisor to see how close I can get to 8m to the 4th. So I multiply 2 times 4, that can give me 8, and m squared times m squared to get m to the 4th. 2 times 4 is 8. M squared times m squared is m to the 4th. Then I change the sign. That gives me a subtraction. I get 0. Bring down my next term. Positive 4m cubed. Don't forget to bring down the sign. 2 times what gives me 4? That would be a positive 2. Again, I need the sign. M squared times what gives me m cubed? That would be m. 2 times 2 is 4. M squared times m is m cubed. And we change the sign. That turns this into a subtraction. That gives me 0. Bring down the last term. That's a negative, which is a minus, 2m squared. 2 times what gives me a negative 2? That would be a negative 1, therefore minus 1. M squared stays the same. So 2m squared times a negative 1 is a negative 2m squared. Now I change the sign. That gives me a subtraction, gives me a remainder of 0. Since that is a remainder of 0, I know that 2m squared and 4m squared plus 2m minus 1 are factors of this polynomial. Let's look at one more example with a monomial. Here I have a dividend and my divisor. I set it up just like my numerical example. And I'm going to divide 7k squared into 14k to the 5th. That would give me a 2k cubed. 7 times 2 is 14. K squared times k cubed is k to the 5th. Change the sign. That's going to give me 0. Bring down the negative 28k to the 4th. 7 times what gives me a negative 28? That would be a minus 4. K squared times k squared gives me k to the 4th. 7 times a negative 4 is a negative 28. K squared times k squared is k to the 4th. Change the signs. Gives me a subtraction. I get 0. Bring down the positive 35k cubed. 7 times what gives me 35? That would be a positive 5. K squared times k gives me k cubed. 7 times 5 is 35. K squared times k cubed. Change the sign. Gives me a subtraction. I get 0. Bring down my minus sign. 7k squared. 7 times what gives me a negative 7? That would be a minus 1. 7k squared times a negative 1 is a negative 7k squared. Change the sign. I get 0. Since my remainder is 0, I know that my quotient and divisor are factors of my polynomial. In my next example, I want to divide a polynomial by a binomial. In this instance, we want to write the terms of the dividend, here the polynomial, in descending order of the exponents. We've done that on our previous examples, k to the 5th, k to the 4th, k cubed, k squared. And we are doing it here also, x squared, x, and of course x to the 0, but that is 1, so we don't show that. But the key here is, if a term is missing, in other words, one of these descending order terms, then I have to insert a 0 or 0 coefficient as a placeholder for that value. This doesn't have that as an example, but my next ones will, to show you how that works. Here I am in descending order, x squared, x, and then my number. So I'm just going to place this in the example exactly like my numerical example with my dividend and divisor. What I want to do is start with my first term in each my binomial and polynomial, or divisor and dividend. X times what gives me x squared? Don't concern yourself with the next terms. They'll generate themselves. X times what gives you x squared? That would be x. X times x is x squared. And now I actually distribute. X times x is x squared. X times a positive 4 is a positive 4x. Now you can see my terms line up, so they're like terms. As I did on my monomials and numerical, I need to change the signs. Here I just changed the signs of both terms. Positive goes to negative, positive goes to negative. Now, since they're opposite signs, I'll subtract. X squared minus x squared gives me 0. I don't need to place that there. I know it's 0. 3x minus 4x is a negative x. Bring down the minus 4. Again, I want to concern myself only with the first terms. X times what gives me a negative x? That would be a negative 1. Now I distribute. A negative 1 times x is a negative x. A negative 1 times 4 gives me a negative 4. Again, as in my previous numerical and monomial examples, I want to change the signs, but here I'm going to change both signs. Positive, since that's negative, and to positive, since that's negative. I change both signs. That sets up a subtraction. Negative x plus x is 0. Negative 4 plus 4 is 0. In other words, I have a remainder of 0, and each are factors of my polynomial. Let's take a look at another example. Here, I want to divide again a polynomial by a binomial. Again, this is in descending order. I must check that, n squared, n, and a number. So I set it up just like my numerical example. Again, I want to check first term to first term only. N times what gives me n squared? That would be n. Now I distribute. N times n is n squared. And n times a negative 4 is a negative 4n. Change the signs. This positive goes to a negative. This negative goes to a positive. N squared minus n squared is 0. Negative 5 plus 4 is a negative n. Bring down the next term and its sign. N times what gives me a negative n? That would be a negative 1. Now I distribute. Negative 1 times n is a negative n. Negative 1 times a negative 4 is a positive 4. Change each term sign. Negative to positive, positive to negative, and I subtract. That leaves me 0. And with a remainder of 0, I know each are factors of my polynomial. In my next example, I have a binomial dividing into a polynomial, and my polynomial is in descending order, so I can set that up just as my numerical examples. Again, I want to check my first terms only. m can go into 2m cubed, and what will multiply that to get that to happen is going to be 2m squared. And I want to distribute. That gives me 2m cubed minus 6m squared. Now I change the signs on each. That gives me subtraction. That's going to give me 3m squared. Bring down my next term, which is a negative 10m. M times what will give me 3m squared? That's going to give me a positive 3m. Now I distribute. 3m times m is 3m squared. 3m times a negative 3 is a negative 9m. Change the signs. Negative, positive. That gives me a negative m. Bring down my minus 3. M times what will give me a negative m? That's a negative 1. Multiply. When I distribute through, it's going to give me a negative m plus 3. Now I change the signs. Positive, negative. My m's cancel out, and that gives me a negative 6. Therefore, my solution is 2m squared plus 3m minus 1, remainder of a negative 6. Therefore, this and this polynomial are not factors of my original polynomial, since my remainder is not 0. Again, I have a remainder of a negative 6. In our next example, our dividend is 4x squared plus 7x, and our divisor is 2x minus 1. We can see that this is descending order, but I'm missing an element of that order, which is our constant. So when I set up our example, I have to put this in descending order, but I have to put a place value in for my constant. Therefore, it's 4x squared plus 7x, and the placeholder is 0. Now I perform the same operations I did on the previous examples. 2x times what gives me 4x squared? That would be 2x. 2 times 2 is 4, x squared. 2 times a negative 1 is a negative 2x. After I distribute, now I change the signs. That's going to be a negative 4x squared plus 2x. When I subtract, that's 0. 7x plus 2x is 9x plus 0. And now 2x times what will give me 9x? That's going to give me a positive 4. That's as close as I can get. I distribute. 4 times 2 is 8x. And 4 times a negative 1 is a minus 4. And I change the signs. And when I subtract, I get x plus 4. So my solution is 2x plus 4 with remainder of x plus 4. And you can see the reason why we put a placeholder in is to make sure that we have like terms all the way down in our solution. Our next example, we have our dividend of 3x squared minus 16 and our divisor of x minus 2, a binomial. When we set this up, we realize that I do have this in descending order, but I'm missing an element. I'm missing my x value with an exponent of 1. So what I do is I have 3x squared. My placeholder is a plus 0x, which is basically just 3x squared minus 16, with my constant at the end. And I proceed as usual. X times what gives me 3x squared? That would be 3x. Then I distribute. 3x times x is 3x squared. 3x times a negative 2 is a negative 6x. Now I'm going to change the signs. And that's going to give me, when I subtract, the x squares cancel, and that gives me 6x. And you can see, again, that placeholder gives me like terms so I can perform this operation. Now I bring down my minus 16. Again, x times what gives me 6x? That would be plus 6. 6 times x is 6x. And 6 times a negative 2 when I distribute is negative 12. Change the signs. 6x minus 6, that cancels. 16 and 12, that's negative, so that's a negative 4. Therefore, I have 3x plus 6 with a remainder of a negative 4. Therefore, on each of these last two examples, x minus 2 and the quotient are not factors of the original polynomial because I have a remainder of each. Remember, for it to be a factor, I must have a remainder of 0. In this example, they want us to determine whether each binomial is a factor of the given polynomial. In other words, I want to use x plus 4 as a divisor, use this as a dividend, and when I divide into it, if a remainder of 0, then this is a factor. If it's not a remainder of 0, then it's not a factor. So let's proceed with the same process we had before. First, let's check descending order. X cubed, x and the number, it is in descending order, but I'm missing an element. I'm missing the x squared. Therefore, in our example, I'm going to put a placeholder in, a 0x squared. Now that completes my descending order. Then I just follow the same procedure as I have. So x times what gives me x cubed? That would be x squared. X times x squared is x cubed. Distribute gives me plus 4x squared. Change the signs. That gives me a negative 4x squared minus 13x. X times what gives me a negative 4x squared? That's a minus 4x. Distribute. That gives me a negative 4x squared. That gives me a negative 16x. Change the signs. X squareds drop. That gives me 3x. Bring down my plus 12. X times what gives me 3x? That would be a positive 3. Distribute. 3x. 3 times 4 is 12. Change the signs. Everything drops. That gives me a remainder of 0. Since I have a remainder of 0, I know that x plus 4 is a factor, and also x squared minus 4x plus 3 is a factor. So the answer is yes, it is a factor. Let's check out the next example. Is x minus 2 a factor of our dividend? Again, I put a placeholder in for my 0x squared. Now I have it in descending order, and I'm going to follow the same process. X times what gives me x cubed? That would be x squared. Distribute. That's going to give me x cubed minus 2x squared. Change the signs. That's going to give me the x cubes drop. That's 2x squared. Bring down the minus 13x. X times what gives me 2x squared? That would be a plus 2x. Distribute gives me 2x squared minus 4x. Change the signs. That gives me negative 13x plus 4 is going to give me a 9x. Negative. Bring down the 12. Positive 12. And x times what gives me a negative 9? That would be a negative 9. Negative 9 times x is a negative 9x. And negative 9 times a negative 2 is a positive 18. Change the signs. And 12 and a negative 18 gives me a remainder of a negative 6. Since x minus 2 gives us a remainder of a negative 6, this is not a factor of my dividend. So the answer here is no, it is not a factor. Again, remember why we put a placeholder in is that we can have like terms as we proceed through our example. On both cases, we were missing elements. We put in a placeholder for that element, and that gave us our like terms.